All right, microphones. So there's different microphones for different applications, generally instrument or vocal miking. They differ depending on their internal circuitry. They can pick up sounds differently, alter sounds differently, and the use of the right microphone the right way requires knowledge of the different types of microphones. So we'll get into all those different microphones. So we have dynamic microphone. It's probably the most versatile. It's generally what most people buy. Can be used on both instruments and vocals, can handle loud volumes really well. They're very durable. Like if you've forgotten your hammer, you can just use one of those, it's fine. And they provide good gain before feedback. It's generally just because they're not as sensitive. So the mics I used yesterday, just pull one out. This is a dynamic handheld microphone. This one's from Sennheiser. The one up there is Shure's. That's an SM58. It's probably one of the most common ones. There's also the 57. This is their instrument mic. This is their vocal mic. It's the same mic, just a different end. So if you ever need to mic an instrument, you only have 58s. Just unscrew the top. It's the same capsule and everything. All this is it's a grill to protect it, and there's an integrated pop filter, so that helps with vocals. Yeah. So here's the sort of internal workings of it. You have a thin metal coil for detecting sound. When the diaphragm vibrates, the coil moves back and forth past a magnet, creating a current. It is sort of the least sensitive. So these are sound waves. They're hitting this diaphragm. This coil is connected to the diaphragm, and there's a magnet. If you take a coil, you move it past a magnet, you create voltage. And it'll be alternating. And then that's wired out, and that's where you get your signal from. Condenser mics. I have a couple on stage here. Our lectern mic is a condenser mic. The drum overheads, there's a mic in the drum kit that's a condenser. The audience, those are my choir mics. I'm just testing them out as audience mics right now. They provide a stronger signal than dynamic mics, because generally more sensitive and responsive. They're preferred over dynamics when fitting, so they're not great in loud stages. I know a few people are like, they're never for live stage because you're just going to pick up everything else. Generally a little less durable, a little more finicky, and then they require power. So some condenser mics will have a spot for a battery. It's usually like shotgun mics for video. There'll be a little slot for like a AA in there. But the most common way we use it is we'll just send phantom power from the board. So, works eerily the same, because they're all, it's called a transducer. It's changing the form of energy. We're going from air pressure to electrical energy. You've got backplate and so condenser is an obsolete for capacitor. So you have two plates with a voltage between them. When the diaphragm vibrates, it changes the distance between those plates. So it's a capacitor, so as it pushes in, it's now discharging. And then when it pulls up, it's sort of filling up. So you create your positive, negative, alternating current there. And so that's why it needs the power, is it's using it to sort of power those magnets. Ribbon mic, won't see a lot of them on a stage. They're really great for electric guitar. Everyone with electric loves ribbon mics. They're really, really sensitive. Tend to have a very flat frequency response, but they're very fragile. Like, if you look at it wrong, it's broken. And they're generally expensive. And they can go up to thousands of dollars. Yeah, in most recording studios, any amp recording you've heard, like from a guitar, that's generally a ribbon microphone. It could be something else, but the Royer makes one that's like sort of synonymous with electric guitar. Now the funny thing is, this is the easiest one that you could build if you ever wanted to build your own microphone. You just need couple of magnets, 3D printer, and then you have to buy some really thin foil. So this ribbon is, it'll be a piece of foil that's microns thick, like think gold leaf type of thinness, a bit thicker than that. But it gets corrugated and then sort of connected between the magnets. So that corrugation allows it to bend back and forth between the magnets, and that's what creates your voltage. And then it'll hit a transformer, and that'll output your signal. These do not like phantom power. You ever heard make sure you don't turn on phantom power, you'll wreck the mic? They're talking about ribbon mics. Most dynamic mics don't care. Like if you send, it doesn't need it, but it won't hurt it. This, because of how thin that metal is, it can sometimes just and then if you overdo them too, like just too loud of a sound, you can bend them out basically, and then they won't work either. So like I said, they're very sort of fragile mics. So yeah, like I said, on our stage, we'll generally use dynamic mics. There's a couple spots where we'll use condensers, and you don't really see a lot of ribbons. There's a couple other kind of mics that we generally don't deal with either, that I won't get into. But the bigger thing that you should be thinking about is probably polar pattern. So that's the pickup pattern of the microphone. Where does it get sound the best? So the polar pattern will help us choose the correct microphone for the right application. There's a bunch of other ones, but the most common would be like omnidirectional cardioid, hypercardioid, and shotgun. Guys, any of you guys heard of those terms? Yeah. So I'll go through each of them here. I used to do omnidirectional first, and I realized that it didn't make any sense because it was just a circle. So we'll start with cardioid. The benefits of cardioid, and most of these mics are going to be some version of cardioid, is you get good feedback rejection. So if you look at that picture there, think of that as a slice of a 3D image. So if we're holding the mic like this, that's like that, but all the way around type of thing. So what that's saying is at 0 degrees, so right on the top, you're getting the best pickup. It's not cutting it at all. As we go to 90 degrees, you can see there, follow that line, it's getting a 5 dB cut at 90 degrees. Then as we go around to 180 degrees, its pickup is 0. So it's blocking the sound from here, and then it's just slowly increasing the volume until the front where it's the loudest, and then it cuts it again to the side. Some of the negatives is setting up this off axis will change the sound a bit, so you end up with something called proximity effect. So with this mic, which is omnidirectional, as I move it closer, it generally just gives you more volume. With these, as you move closer, you get more bass. So as you go up and up, you're going to get more and more of that low to low mid range, which can sometimes be beneficial. That's the AM radio voice, or the radio host voice. It's because they're right on their microphone like this to get that low end thickness. One of the main ways that I think about using this isn't so much where do we point this. Like we always point, you want to get this sort of pointed at the talent, whoever's singing or talking. If you have a lot of problems with like plosives, like sounds, then just sort of rotate it around, and then they're talking. That air pressure goes past the microphone, but they're still being picked up by the most responsive part. The big thing to think about is if you have a stage wedge, that's your cause of feedback. If you're having feedback problems, point the least sensitive part of this microphone at the wedge. So I want this pointed here, but I can do that in a bunch of different ways. if my wedge is here, then I want this part pointed there. If you think about a piano, generally if they have a wedge, it's going to be on the ground to their side. So if you do this, you're going to get less pickup from there, but you'll get about the same amount of signal into the front of the mic. So that'll help if you're having feedback problems. Just point your null at whatever you don't want to be picked up. Omnidirectional, you get less popping plosives, no bass buildup, no chance of speaking out a pattern. That's generally why these are omnidirectional. It's because they can sit sort of wherever and it'll pick it up. But they're prone to feedback because they're just literally picking up everything from everywhere. So this still has a circle, it's just all the way around. Hypercardioid. I have one of those here. They look the same, doesn't really matter. The benefits is if you have a really loud stage, your cardioid is sort of picking up quite a bit. This sort of tightens in that pattern, so it's more directional here and cuts off more from the sides. But when you get that, you get this lobe in the back. So if you're using a hypercardioid microphone, you don't want to put your wedge directly in front of the singer. You want it off to the side, because then it's hitting that null point, which is here, not here. Yeah, so the question was using it for someone where the wedge is going to be on the side. Yeah, this is a, you can have a cardioid mic, like I said, you just sort of point it to the side, but this is a better one where you wanted to point it straight on, but have that rejection from the side. Another use for this is in like bigger acts, like they still want wedges, but they want stereo, so they have a left and a right wedge. So it's not in the middle, it's now off to the side. So you go with a hypercardioid because now the nulls are pointed at both of the speakers. Shotgun, mainly used in video. They're good for audience mics. The idea is like they can reach further, but it's not so much that they're reaching further, it's just they're more sensitive in really narrow spots, so you can really sort of turn up the gain without getting a bunch of stage sound out of them. So we use these for audience mics for our live stream, so you can hear the congregation in the live stream. But then you can also use these if you're filming someone one-on-one. You can just stick a mic out of frame pointed at them, and it'll just sort of pick up what they're saying. Figure 8. It's like usually those old square microphones, more often used in recording, but they just pick up on both sides. They reject, or the front and back, and then they reject from the side. The other thing with microphones you have to look out for is when you buy them, they'll actually generally come with one of these frequency response charts. I think this one's for an SM57. And it'll tell you how the microphone is EQing the sound. So even before you get it, the microphone is already doing this. So one of the best places for an SM57 is on snare. It's a snare mic. A lot of people love it for that. And that's because there's this boost right here where you're looking for that sort of snap and sizzle from the snare. And then you have a bit of roll off from 200 hertz down. It's still picking up really low frequencies, but it just starts turning them down as well.